Okay, this presentation we're going to look at the exponential distribution, and what we're looking at in this particular instance is laptop lifetimes. Now, the exponential distribution is typically used to model the lifetimes or durations or some period of time. Okay, so the average lifespan of a laptop is 5 years. That's good going. So we're going to say that mu is equal to 5. Mu is the mean. Okay. You may assume that the lifespan of computers follows an exponential probability distribution. Okay? Usually you should be told that. You know what I mean? You will get told that explicitly in a question. So, what is the probability that the lifespan of the laptop will exceed? It would be at least 6 years, exceeding 6 years. And the second question is, what is the probability that it will not exceed 4 years? Now, so what we could do there is actually just state that X is the lifetime laptop. Okay, so X, just make a little statement like this: X is laptop lifetimes. Usually you would sort of say what time unit you were using as well, just in case you switch from years to months or something like that. Also, you should state that X is exponentially distributed with a rate parameter of, here it is 1 over 5. Okay, lambda is the rate parameter, and we know that lambda is 1 over 5 because lambda is equal to 1 over mu, and that is 1 over 5. So the rate parameter and the exponential mean are reciprocals of each other. Okay, sorry, yeah, there we go. Sorry, I just actually sort of went into it there. So we are told that the exponential mean mu, which is here, here we are told the exponential mean mu, which is related to the rate parameter. So anyway, when you start off a question, have a little statement like this. And actually, not that you need it 100%, but actually it's just actually specify what time units your variable is denominated in. Just that's something I particularly like. Now, so what we're going to do here, sorry, actually I'll just write that out. That's exponential of minus k divided by mu. Okay, just in case that's a little bit hard to read. And that's 1 minus the exponential of that. So k is some particular value that we're interested in, and what we do is divide it by the mean. Okay, so the probability of x greater than k is this expression here. The probability of x less than or equal to k is this expression here. This is actually the cumulative distribution function, also known as the CDF. Okay, here k is some particular value. It doesn't really matter. Or it's 6 and 4 actually in the two questions. So, using these two expressions, okay. Something. Sorry, just before I continue, I have them denoted here as greater than or equal to, and less than or equal to. And I'm working on the basis that these are complements of each other. Now that's not exactly true. But just for continuous random variables, the probability of x equal to k is considered negligible. Okay, so that you can sort of get away with stating that. Now that's something I would be happy with, but just double check otherwise. Also, actually, just greater than or less than and not having an equality component, that's also actually equally acceptable. Okay, but you typically don't get asked for it. It's sort of assumed when you're dealing with continuous random variables that you can exchange one or use one of these as the complements of each other. Now, so the first two questions are greater than 6 and less than 4. So in the first case, it's the exponential of minus 6 over 5, and in case you can't read that, that's the exponential of minus 6 over 5, which is the exponential of minus 1.2. Little bit of calculator work, that works out to be 30.12%, 0.3012. The second question asks us the probability of x less than or equal to 4, and that is using this expression here. That is the 1 minus the exponential of minus 4 over 5, okay? And that is 1 minus the exponential of 1 minus that, actually. And that works out to be 0.5506, okay? Now, what we're going to look at here in part C, sorry, that's part A and B. The part C is, what is the probability of the lifespan being between 5 years and 6 years? Okay. So in the first case, what we're going to do is look at it this way. Now, I actually don't have a similar video with similar sort of numbers, but I took a different approach to it. So what I'm going to sort of start off with saying in that video, so I'm going to take a different approach at this video. So this is inside an interval. And this is the complement of that, which is outside the interval. Okay. Now this is a sort of handy way of getting the hang of this sort of stuff. So this is broken up into two parts. So I'll just come down to that one shortly. Too low for the interval is probability of x less than or equal to 5. Okay. So that's 1 minus the exponential of minus 5 over 5. That's 1 minus the exponential of minus 1. And that works out to be 0.6321. Okay. And then too high for the interval is actually probability of x greater than 6. And we actually figured that out previously. That's 0.3012. That's part A. Typically, you should be recycling a couple of values in your exam question just to sort of save time. Okay, so this expression here of being outside the interval is broken up into two components, and we each have the too low component has a probability of being 0.6321. Too high, 0.3012. Okay, so what we end up with there is the complement of that. Add them together, get the complement of that, and that should work out to be 6.67%. Now, these numbers are very similar to a different video, and I'm sort of conscious of that fact. It's just that this video, I approached the problem from a slightly different way. Okay, so that's good. Yeah, we'll leave that there.